Okay, this episode will include the basics of charging by friction and specifically which way the electrons will move and conservation of charge. So when you use friction, friction's a force. The direction of the electron flow is going to be based on electron affinity, how much a particular material is good at grabbing electrons. Now in this table that we got from physicsclassroom.com, materials on the high side of the table have a strong electron affinity, and materials on the low side have a weak electron affinity. So the items on the top will take electrons from items that are lower down. So if we should rub silk against glass, which is one of the things we tried in the lab, uh, because silk is higher on the table, the electrons will go from the glass to the silk, making this negatively charged and leaving behind positive charge on the glass. And again, it's not that we gained or created a charge, it's that we moved charge. And the only thing we're moving are the electrons. Protons are stuck in the nucleus. They're not going anywhere. Now, when we do move charge around, that charge must be conserved. Like momentum or energy, which we've just got done studying, if you look at a system, all the objects in the system, any charge lost by one must be gained by another. Now, again, it's not being created, it's just being moved around from place to place. So I've got a wool sweater and a cotton shirt. Now, from the table up above, the wool is lower down on the table than the cotton. So electrons will move from the wool to the cotton if they are rubbed against each other, and then that will make the leave behind excess positive charge on the wool sweater, and it will take extra electrons to the cotton shirt, so it will end up negative. Now if I move 4 electrons to the shirt, then I will have left behind 4 extra protons on the sweater. Now the total charge of this system did not change. Initially it was 0 because I had 1 electron for every proton. Now on the left the wool sweater is plus 4 and the cotton shirt is minus 4. Well, when you add those two together you get 0. So we haven't changed the total, we've just transferred it from one object to another. Okay, so keep that in mind whenever you're looking at charging something. You're not creating charge, you're moving it from one place to another. So a quick check for understanding. During the physics lab, the plastic strip is rubbed with cotton. The cotton became positively charged. Now, it could not have acquired extra anything, whether protons or electrons, and we couldn't have created it. All right. So it's not that the protons never move and we never create anything. All we did was lost electrons from the plastic to the cotton. Now that means the cotton became positive, and that means the plastic strip would have become negative, but the total net charge would still be 0. If we go up and look at the, or in this case, the saran wrap has a larger electron affinity. That means the saran wrap would be higher on the table than the nylon. Since that's the case, electrons will go from the nylon into the saran wrap, and the saran will become negatively charged. The nylon would end up being positively charged. Again, if we look at the system, the net charge started at 0, so the net charge would have ended at 0. We didn't create charge, we just moved it from one place to another, and it was only the electrons that we moved. So those ideas should help us to pick out the ones from here that are actually correct. Glass object and a felt cloth, the glass is going to become positive. Now that means the felt's going to become negative. That means the electrons went from the glass to the felt. Okay, so no gaining of protons. The felt did become negatively charged. That is correct. Charge is never created, so it can't be that. If the glass acquired plus 5, then the felt acquires negative 5. That's conservation of charge. We got equal but opposite amounts, so yes, that's true. It does not violate the law of conservation of charge. It really can't. because it is a law of conservation of charge. There's no way for us as humans to get past that law. Electrons are transferred from the glass to the felt. That part's correct because we do go from positive to negative. Protons are never transferred from anything, so no protons are transferred. Once charged in this manner, they should attract each other. Well, that's true because opposites attract. So we could get them to stick together at that point. In general, glass materials must have a greater affinity for electrons than felt materials. Now again, the electrons will move from less affinity to more affinity. So it's actually the glass material should have less affinity than the felt does. And finally, which of the statements best explains why a rubber rod becomes negatively charged when rubbed with fur? It has nothing to do with its properties in terms of an insulator. Okay, it's about the electron affinity, how much it attracts molecules, electrons. Now, to get the electrons to the rubber to become negatively charged, that means the electrons have to go to it, leaving behind the positive charge on the fur. So that means the rubber rod has a stronger attraction, is going to pull the electrons from the fur. So it is this one. It's not that the fur has a stronger attraction. If that were the case, the fur would become negative and the rubber rod would become positive, but that's not what happened. Okay, so that's some of the basics of what happens when you charge by friction. We'll also be looking at conductors, insulators, and polarization as we move ahead.